Hello students, welcome back to the Tantray Sir physics classes. I have come up with one more challenging problem in electrodynamics. Presently I am delivering lecture series on uh, challenging problems on electrodynamics. It will take us a few, okay, let us see how many lectures it needs. And then I am also teaching simultaneously rotational dynamics. I have already completed rotational dynamics. Now we are solving its objectives and problems. So it will take us a few more lectures and then we will start gravitation. Okay, the problem is like this. It is a current carrying conductor here, infinitely long. And here is a conductor, conducting rod. It's a rod. And it moves upwards with velocity v. When it moves upwards with velocity v like this, what is induced EMF in the rod? Because it is cutting the magnetic field of this rod, of this conductor. This conductor creates magnetic field around it, and this rod is in that magnetic field, and when it goes up, it cuts that field. When the field lines are cut by the rod, then there is induced EMF. And here it cuts the field lines. जो इस कंडक्टर के फील्ड लाइंस है, अगर ये कंडक्टर है, इसके फील्ड लाइंस यूं है अराउंड, तो यहाँ पर रॉड जो पैरेलल जा रहा है ऊपर की ओर, it goes upwards, it cuts the field lines. We have to see how much induced EMF is developed across the rod. That's our question. You can look at it. A current carrying conductor as a rod at a distance a, and the rod moves up parallel to the conductor, and we have to see how much is the induced EMF. So what we need to do? Here we have a problem. You see, the rod is not in the uniform magnetic field. The magnetic field here is more, then it's decrease up to here, because the points are quite away from the conductor. Those points which are closer to the conductor have more magnetic field. Those points which are away from the conductor have less magnetic field. These points have less magnetic field. So this rod is moving upwards in a varying magnetic field. And that varying magnetic field is not time varying magnetic field, that is space varying magnetic field, because magnetic field varies from here to here. It decreases as you go away from the conductor. So how to do it? So first of all, why not find the flux which it cuts? So what I do is, I will take an element here. Here I will take an element, this one, dr element at a distance r. And this dr element, what is the magnetic field here at this point, then that I can find. And due to that magnetic field, how much is the flux if the rod goes up x? If I differentiate this x, that is velocity, because it goes upwards. So this dx by dt is this velocity. Let me suppose it goes up x. Can we find the flux here? How much is the flux here? That flux I want to find, and then I will find the total flux. So what is d phi? Small flux in this region. Here magnetic field I know. Magnetic field into this dr into this x. That is the flux in this region, this one. So that is mu 0 I by 2 pi r is the magnetic field here, because this point is how much away from the conductor, or this is the magnetic field, dr into x, that's the area of this element, dr into x. This is the flux. This flux stripped, this flux, this one. So, but I have to find the total flux in this region. So that I can do by integrating. So it is d phi is equal to, okay, that is mu 0 I x by 2 pi dr by r. Integrating both sides, I will integrate like this. This is a constant in the given situation, and here you can integrate from a, from here to here. So there is a to a plus l. So what is flux? Total flux in this region of in this x region, right? That is mu 0 I x by 2 pi. It is ln of r a to a plus l. A plus L. So flux is equal to mu 0 I x divided by 2 pi ln of, ये वैल्यू देना पड़ेगा R को पहले, A plus L, फिर माइनस करके ये वैल्यू देना पड़ेगा और फिर उसको कंबाइन करके ये A यहाँ आ जाएगा. So it will be ln of A plus L minus ln of A, but that can be put into ln of A plus L by A. Okay? So that is the flux. I got the flux. It is the flux which it cuts when it goes up the upward direction. But what is induced EMF? The induced EMF is rate of change of flux. Because when the rod goes up, this x changes. When this x changes by the motion of the rod, that means this x when changes, that will change the flux. The moment flux changes, there is induced EMF. So rate of change of flux is induced EMF. That is what we know. So how to do it now? Now differentiating this equation. So it is d phi by dt is equal to, okay, mu 0 is constant, I is constant, 2 pi is constant, ln of A plus L by A is constant. The only variable parameter is x, because when the rod goes up, this x changes. But change in x is definitely so velocity. So it is dx by dt. Differentiating this, and here on the right side we need only to differentiate this x. Other parameters are constant. So it is induced EMF magnitude, otherwise it is negative. It is mu 0 I by 2 pi ln of A plus L by A into V, this V. But we need, let us write this V here. Okay, V. So magnitude of induced EMF is mu 0 I by 2 pi, V right here, ln of A plus L by A. I would write this V here because it should not be confused with A plus L by A into V. It is not this parameter into, this separate, therefore I put it here to avoid confusion. So this is the equation, this is the expression for induced EMF developed in the rod. So the question was like this. Here it was a current carrying conductor straight up. Here it is a rod like this. The rod was moving parallel. The rod was moving. This is a conductor. This is a rod. The rod was moving parallel to the conductor upwards. It was cutting its magnetic field. This circular magnetic field. It was cutting it, and we had to find what is the induced EMF. The challenge was there like this. The magnetic field from here to here was not constant. So it was not cutting the constant magnetic field. Otherwise, we would have written straightway VBL, velocity, magnetic field into length of the rod. But the situation was the current carrying conductor was not creating the magnetic field constant from here to here. It was a variable magnetic field. It was space varying magnetic field. Therefore, we need to do some calculus, and that makes the problem very nice one. It's a good one. Problem. And this conductor, when it moves up, the x distance that it covers the upward direction changes. Therefore, the rate of change of x is velocity. And finally, we got the answer, mu 0 I V by 2 pi ln of A plus L by A. Thank you. But don't forget to watch my lectures on the YouTube, and also I have an application available there which can be downloaded from Google Store. And from there you can find literature, objectives, problems, all sorts of physics problems there, which are good for what you call as NEET students. It is good for IIT aspirants also. Thank you.